The ScanMed corridor runs from Finland all the way down to Malta, and thanks to a bridge over the sea at Copenhagen, it's all pretty easy going, until you reach that rather large mountain range called the Alps. For decades, that's slowed travel down, creating a tortuous bottleneck on what's otherwise a very slick route. To solve the problem, the EU is now digging an $11 billion tunnel directly through the very heart of the mountains to effectively link Scandinavia with the Mediterranean. It's an astounding feat of construction that will better connect a continent. Believe it or not, this picturesque valley is actually one of the most important links between northern and southern Europe. Sitting 1,371 metres above sea level, the Brenner Pass is the lowest passage through the Alps and can be used all year round. In 1867, the Brenner Railway was built to improve capacity, and by the 1970s it was joined by the E45 motorway, creating a major freight thoroughfare for traffic heading from the North Sea down to the Mediterranean and vice versa. Today, the Brenner Pass carries 40% of all freight over the Alps, but due to the steep inclines that you'd expect to find in the Alps, and the impact that has on reducing the speed of trains, over 2/3 of freight actually travels by road. This, combined with the leisure market in the region, made the area notorious for traffic jams, noise and poor air quality, and in 1994 the EU decided to take action. Modifying the existing railways is pretty impractical due to the terrain, so the decision was made to construct an entirely new railway directly through the mountains, somewhat dramatically getting around those steep inclines and meandering routes that slow trains down. Starting at Innsbruck in Austria and connecting to Fortezza in Italy, the main route of the Brenner-based tunnel will run for 55 kilometres. When connected to the Innsbruck bypass tunnels built in 1994, the project will become the longest underground rail connection in the world, with a total length of 64 kilometres, surpassing even the Gotthard-based tunnel in Switzerland. The overall project consists of an exploratory tunnel used to gauge the route's conditions prior to construction and to act as a drainage system on completion, twin main tunnels set 70 metres apart which will carry trains in either direction, and 4 lateral access tunnels that connect to the surface and allow for spoil and materials to be moved in and out. If that weren't enough, the 2 main tunnels are connected every 333 metres, and 3 emergency stations have been constructed 20 kilometres apart to provide escape routes and refuge for passengers. Works first began in 2008, and excavations now been progressing across 4 main sites for more than a decade. It probably won't surprise you that digging a long tunnel through a mountain is not easy, and this is no exception. The route happens to run through 4 distinct rock types and one of Europe's longest fault lines, so construction of the tunnels consists of a roughly 50-50 split between traditional blasting and the tunnel boring or TBM methods. For sections created by blasting, explosives are loaded into pre-drilled holes and detonated. Loosened material is then removed with heavy machinery in a process known as mucking. Once cleared, shotcrete is applied to stabilise the surface and anchors, and lattice arches and reinforcement mats are installed to provide structural support. The whole process then moves forward and repeats itself. The TBM sections are, in principle, much simpler. The machine excavates material, removes it via conveyor belts, and applies tunnel reinforcement itself as it moves forward through the rock. Regardless of which method is used, once excavated the tunnels are completed in largely the same way, with only minor differences to their final appearance. With an inner diameter of 8.1 metres, the project will see an incredible 21.5 million cubic metres of material excavated altogether. We're not sure how many yodels that's equivalent to, but it's a lot. Around a third of this material will be recycled, reused as concrete aggregate within the tunnel itself. The rest will go to 5 sites along the route to be disposed of in a sustainable way, acting as fill for areas that can be reforested and landscaped once the project is complete, returning the site to its original use. When it finally completes in 2028, some 20 years after construction first began, the incredibly direct Brenner Base Tunnel will allow trains to reach 200 km an hour, and the journey from Innsbruck to Vorteza will go from 80 minutes to just 25. It's a feat of construction that'll create a cleaner and more sustainable transport link, not just through a mountain range between 2 countries, but from Scandinavia all the way down to the Mediterranean. If you enjoyed this video and you want to get more from the definitive video channel for construction, subscribe to the B1M.